Let us explore the realm of technology.
AI, machine learning, neural networks. You hear these buzzwords everywhere, and if you're tired of hearing them without really knowing what they mean, well, you've come to the right place. In the next few minutes, we're going to cut right through all that noise and see how a really powerful tool called TensorFlow is making artificial intelligence a reality today. So, this is the big question, right? It's the one that trips almost everyone up. These terms get thrown around like they're the same thing, but they're absolutely not. So let's build a quick, simple map to see exactly how they all fit together. First up, we're going to untangle this AI bus. Seriously, by the end of this little section, you'll have a perfectly clear picture of how these concepts relate to one another. Promise. Okay, the easiest way to think about this is like a set of Russian nesting dolls, one inside the other. The biggest doll, the entire field of study, that's artificial intelligence. Then you open it up, and inside you find machine learning. That's a specific part of AI. And then you go one level deeper and you find neural networks. That's a specific and really powerful type of machine learning. See? AI, then ML, then NNs. So at the very highest level, AI is just this big, broad goal. Let's automate tasks that normally take a human brain. Now, this isn't some new idea. We're talking it dates all the way back to the 1950s. But how we're trying to achieve that goal has totally, fundamentally changed. And that change is, well, it's everything. Early AI was all about rules. Programmers had to sit down and literally write millions of "if this happens, then do that" statements to try and cover every single possibility. It was brittle. But modern AI, it's completely different. Instead of feeding it rules, we just feed it tons and tons of data, and it learns the rules for itself by finding the patterns hidden inside. It basically teaches itself. And that right there, that's the secret ingredient to all modern AI, this incredible ability to learn directly from the patterns that are just sitting there, hidden inside data. I can't stress this enough. Without data, modern AI just wouldn't exist. It's that simple. You can think of data as the fuel, or maybe the textbook that the machine is learning from. The more good data you give it, the smarter your model can get. For example, take this famous dataset from the Titanic. A machine learning model can scan thousands of rows just like these. Now, it doesn't know anything about history or ships or icebergs, but by just looking at the features, like what passenger class were they, male or female, how old, and comparing them to the outcome, did they survive or not, it starts to see patterns. It might figure out, all on its own, that being a female in first class gave you a really high chance of survival.
So how do developers actually build these amazing models that can learn from data? Well, that's where the ultimate toolbox comes in, TensorFlow.
Think of TensorFlow as a massive set of Lego blocks, but for machine learning. It's a free, open-source library that Google created, and it gives developers all the tools they need to design, build, and train these incredibly complex models without having to reinvent the wheel every single time. And what about that name, TensorFlow? The tensor part sounds super intimidating, but it's really not. A tensor is just the basic box for your data in the system. Honestly, you can just think of it as a list of numbers, or maybe a list of lists of numbers that flows through the different parts of the model while it's learning. That's it.
Okay, enough concepts. This is where it gets really, really exciting. Let's actually see what these models, built with tools just like TensorFlow, can actually do.
So let's go right back to our Titanic example. After our model has trained on all that historical data, we can use it to make predictions about passengers it's never, ever seen before. And boom, here's the result. A pretty simple model can predict with about 76% accuracy whether a given passenger would survive. Now, it's not perfect, right? But it's so much better than a random guess. And it did it all just by learning patterns from the data. But it's not just about numbers in a table. Machine learning can also learn to see. Let's check out a model that was trained on a huge data set of thousands of fashion items. The process is actually pretty similar to the Titanic example, but instead of passenger data, it's looking at pixels. The model gets fed thousands of images of clothing, and each one is labeled. This is a shirt, this is a dress, this is a boot. And over time, it slowly learns to connect the specific patterns of pixels with each label. So after all that training, you show it a completely new image, one it's never seen before, and it can predict with confidence, that's an ankle boot. This exact same idea, learning visual patterns, is what's behind almost all modern computer vision. It's what powers your phone's camera, facial recognition, even self-driving cars. Okay, so prediction and classification are amazing. But can a machine be creative? Let's look at our final and maybe the most mind-bending example of all. Get this. A model was trained on the entire collection of Shakespeare's plays. It didn't just memorize the words, it actually learned his vocabulary, his rhythm, his sentence structure, his unique style. Then it was given a single prompt, just one word, Romeo. And from there, it just started writing, generating the rest of the text one character at a time, creating something totally new, but in the style of the master himself. So just think about that journey. We've gone from simple, hard-coded rules to systems that can predict the future, classify images, and even mimic the creativity of Shakespeare. It's pretty clear that this ability to learn from data is an unbelievably powerful idea.
So that leaves us with this incredible new reality. With tools like TensorFlow, we're not just writing instructions for computers to follow anymore. We are building systems that can learn on their own. And the real question isn't just what they'll learn next, but remembering that for the first time, we're building tools that can learn faster than we can explicitly teach them. And that changes everything.
Thanks for watching. If you enjoyed the video, don't forget to like, subscribe, and share with your friends.